Well, we've already made it to problem set number 5, and here's some examples. So this is about integration or finding antiderivatives. Now, at this point in the semester, with what we've learned so far, there's basically 3 types of problems. Number 1, you know derivatives so well that you can look at that and say, oh, that comes from the derivative of natural log of x. So the antiderivative is going to be natural log of x. And then each one of these is going to have the constant of integration plus c. Because when you go to check your answer, take the derivative of this, that's going to be derivative of natural log of x is 1 over x. And the derivative of a constant is 0, and sure enough, that has a plus 0 in it right there. So got that one right. Another type of integral is basically using the power rule. So here we go. So with this one, I can find the antiderivative by adding 1 to the exponent, so that's going to be x to the 4th, and then divide by 4. I'm basically going to do the same thing with this one, but I'm going to rewrite this one first. So for now, I'll just leave the x cubed alone. And then for this one, I could rewrite that as x to the negative 1/2 power. Now we're ready to find each antiderivative separately. So right here, add 1 to the exponent, that's going to be x to the 4 over 4. When you add 1 to this exponent, that's going to be a positive 1/2. So x is raised to a positive 1/2, and then divide by 1/2, and don't forget the plus c. Now this one just has one more step because this is a complex fraction. I need to simplify that. X to the 4 over 4 is fine. But when you're dividing by a fraction, invert and multiply, which means we'll be multiplying by 2. And you could just leave this as x to the 1/2, or you could rewrite it as the square root. Since the original problem had square root, then I'm going to put it as square root. And then this one is done. Then there's one more example for the 3 types of integrals we can do at this point of the semester. And that is if it was like this. Let's say we've got x squared plus 7, and that whole thing is raised to the 12th power, and then it's multiplied by x. So with this method, you use u substitution, and the u is going to be what's inside the parentheses. Because u substitution is basically like the chain rule when taking derivatives, and we need to know not only what is the inside part, but what's the derivative of the inside. So the derivative is going to be 2x dx. Now notice that this original problem has x times dx, and we have x times dx, which is good news. The only thing is, this doesn't have a 2, so I need to get rid of this 2. So either multiply both sides by 1/2 or divide by 2. Keep in mind, in this step right here, you're only allowed to either multiply by a number or divide by a number. There's no adding or subtracting, and you cannot multiply or divide by a variable. Okay, so then going over here, it's going to be integrate, and then inside the parentheses is u, and so that's raised to the 12th, and then times 1/2 du. And then add 1 to the exponent, so that's going to be a 13, and then divide by 13. So it'll be u to the 13 over 13 times 1/2, and at this point, don't forget the plus c. And then finally, you could replace the u with x squared plus 7 raised to the 13, and then it's over 26 and plus a c. Okay, so those are the three main types of problems we could do. Now on to some other examples. So for example number 4, integrate e to the sine of x times cosine of x. So for this one, use u substitution. With this e function, the sine function got substituted into it. So actually the inside part is sine of x. And then take the derivative of sine, which is cosine. And this one matches perfectly because this says you need to have cosine of x times dx, and this one has cosine of x times dx. So it becomes integral of e to the u du. So we start with a more complicated problem, and then u substitution makes it a simpler problem. And the antiderivative of e to the u is e to the u, and of course, plus c. And then finally replace the u. So it's going to be e to the sine of x, and then plus c. And of course, with integrals, you can always check your answer. If you take the derivative of this, you should get this. Well, the derivative of the e function is the e function, so that part's right. And then the chain rule would say also you need to take the derivative of sine, which is cosine. So now I'm confident that this one is correct. I'm going to box it up. There we go. For example number 5. How about if you have integral of the square root of x minus x is divided by x? So for this one, we can't use the power rule because it has to be just a single x raised to a power. Right now we have 3 x's. So what I'm going to do is I'm going to make this into 2 fractions because this is basically saying you have to have this minus this divided by x. That means each one of these has to be divided by x. Or another way to look at it is if you take, for example, 2/17 plus 3/17, of course that equals 5/17. So you can take one fraction and break it up into 2 fractions as long as you keep the denominator the same. So usually we go from left to right, but you can also go from right to left. So this is going to be the square root of x gets divided by x minus x gets divided by x. And then this is an exponent of a half. This is an exponent of 1. So if you subtract those two, it's going to be x to the negative 1/2. And then of course x divided by x is 1. Now do the power rule for integrating. So add a 1 to this, which is going to make it a half, and then divide by a half. And I already know that dividing by a half means multiply by 2. And the antiderivative of 1 will just be x. And then a plus c at the end. And if you want to rewrite that one as 2 times the square root of x, that's good too. Next up, I think this is number 6. How do you integrate sine squared? So when I first look at that problem, I would think, well, inside of the square function is the sine. So I'm going to let u equal sine. I'm going to get a piece of scratch paper right here because I know it's not going to work. But that's how u substitution goes. Sometimes you just try it and it works. Sometimes it doesn't. You have to try something else. So the derivative of sine is cosine. And then this u substitution is saying, hey, if you want this to work, you have to have cosine of x times dx. Obviously we don't, so that's not going to work. So instead, in order to integrate sine squared, you need to use a trig identity. and that is 1 minus cosine of 2x divided by 2. So it comes from the half angle formula, but I think of it as a power reducing formula because it had a square and now it no longer has a square. And by the way, if this said cosine squared, the formula is almost exactly the same, but this would be a plus right here. Now, what I could do is, I'm going to factor this out. So that's a 1/2. I'll just factor out that part. And what's left is 1 minus cosine of 2x. So the 1/2 stays on the outside, and that's going to be multiplied with everything. The antiderivative of a 1 is x. The antiderivative of cosine is sine. Now there's one little detail. In here, the antiderivative of cosine, that's definitely sine, so that's correct. But we also need to do the chain rule. If we were doing the derivative of the inside part would be 2. So we'd have to multiply by 2. But we're doing the antiderivative, which is the opposite. So you divide by 2. And then put a plus c. If you want to, you could distribute so it's 1/2 x, and this one would become a 4 in the denominator, or you could just leave it like that. And for example number 7, well, you're really getting your money's worth today. How do you integrate e to the x over 1 plus e to the 2x? Well, it's time for my scratch paper again. So the first thing that I would try is let u equal the 1 plus e to the 2x. So in other words, the denominator. And then take the derivative of that. So the derivative of 1 will be 0. The derivative of the e function is the e function. Then do the chain rule. The derivative of 2x is 2. Now this little 2 right here doesn't really matter because I could divide both sides by 2. But essentially this is saying in order for this u substitution to work, you have to have an e to the 2x times dx. As you can see, we don't have that. We have e to the x times dx. So that means this u substitution is not going to work. Then what I could do is rewrite this. So it's going to be integral, on the top is e to the x, on the bottom is 1 plus e to the x is squared. Because when you raise a power to a power, that means you need to multiply these two exponents. And that's what that is. Now, inside the parentheses is e to the x. So that's what I'm going to use for the u. u equals e to the x. The derivative of that is e to the x dx. So that means we have to have an e to the x times dx. And right here we have e to the x times dx. So this part right here is going to be replaced with just du. And on the bottom, it's 1 plus u is squared. So once again, we've taken a more complicated problem and turned it into an easier one. And then this is where knowing your derivatives very well will really help you out, because I look at that and I go, I know which one that is. Scratch paper again for a moment. If you take the derivative of tangent inverse of x, it is 1 over 1 plus x squared. So that means the antiderivative for 1 over 1 plus x squared is tangent inverse of x. So for this one, it's tangent inverse of u. And of course, plus c. And then replace the u, so that is tangent inverse of e to the x. and then plus c, and it's done. Well, I hope these examples help with problem set number 5. I'll talk to you again soon.